Hi everyone, I've been planning for some time to explore language models and finally found the time to work on GPT-N. GPT-2 is the last complete model released by OpenAI and it is quite capable. The full model is based on 1.5 billion parameters, which is far less than GPT-3's 175 billion, but keep in mind that GPT-3 has only restricted access through an API and the only model you can truly play around with is GPT-2. Also, if you are interested in understanding the principles of natural language processing, you will end up running even smaller models of GPT-2 that have a few 100 million parameters because the processing power to run the higher models is just not available in a desktop environment. If you plan to run GPT-2 on a local machine with Windows, these are the components you will need to install. First, you need to install Python, and Anaconda is your best bet for this. The advantage with Anaconda is that once you create an environment in it, it will check for compatibility with other installed components every time you install a new component in that environment. It saves you a ton of trouble. The Python version you need is 3.7 because GPT-2 doesn't work with higher versions. We will create an environment with Python 3.7 and install components compatible with GPT-2 in it. For example, TensorFlow 1.15.0. Again, GPT-2 does not work with higher versions of TensorFlow. We will need to install GitHub Desktop also to be able to clone GPT-2 directories from GitHub. We will also use a fork of GPT-2 that has a working train.py file. I switched to a different fork from OpenAI's main model because I found train.py works better on this one. A couple of articles I found useful are included in the video. Just keep in mind that many resources you will find on OpenAI pages, Stack Overflow, etc. are based on Ubuntu or cloud computing versions. If you want to run GPT-2 on a Windows desktop the way I did, the commands will need to be modified. Lastly, I have put all the necessary download links and notes in the description below. One good resource for getting out of copyright books in text format is Project Gutenberg. The pre-trained model itself is trained on Wikipedia pages and open source articles. Alright, let's dive in. The first component we need to install is Anaconda, which is quite straightforward. We need to go to anaconda.com and look under the products tab on that page. Here, only the individual edition is free to use. The others are for commercial usage. Clicking on it, you get to the package page that lists all the components that are included in the installation. You can also look at the use cases of each individual package, though we don't need it for our purpose. Click on download and download the version you require, Windows 64-bit in my case. The installation is quite straightforward as the GUI walks you through each step. Next, we will install GitHub Desktop from desktop.github.com. Again, this is fairly straightforward. Click on download, open the installer, and you're done. Next, I am going to show you an article that I found quite useful. Its link is in the description. It has detailed instructions on how to make the pre-trained models work. This is what I first used to just kick the tires on the pre-trained models. It gives you specific commands you will need, screenshots, etc. It also lists the requirements you have to install for GPT-2 to work, apart from cloning the Git directory. When you clone the directory, it will also download a file named requirements.txt, which you will run as part of your installation process. Some of the commands in the file might not run correctly, though I didn't have that problem. In that case, you will need to run the listed commands manually, installing TensorFlow version 1.15.0 or regex and so on. Post-installation, the pre-trained model can be run through an IDE. This page also lists some sample output from the 774M model. On to the installation process. You will need to launch your Anaconda prompt. Once there, switch to the envs directory within it. Run the command conda create -ngpt underscore env python equal 3.7.0. I made a couple of changes to the list command because I didn't want to confuse my GPT-2 directory with the environment folder later on, so I changed the name. Also, the Python version needs to be specified because simply typing in 3 might create the environment with Python 3.8, which will not work. Once created, activate the environment. You can check the start of the command prompt to see if it is active. Next, you will clone the Git directory by using the command. You can also copy and paste it from the article. In this demo, we are not going to use the OpenAI fork as I said before. I could not get train.py to work. Instead, I am going to take you to a different fork of GPT-2 that has a train.py module that works like a charm. We will use the fork listed in this article. Again, the link is down below. Though this article focuses on using Google Colab, we will modify the commands to make them work on Windows. Here, the names of the models listed are not correct. They have changed to 124M, 355M, 774M, and 1558M, and those are the names we will need to use to download the pre-trained models. The article talks about training the AI on communism books, which led to some interesting outcomes. Okay, on to the main task. You can ignore all the commands related to Colab that is not relevant for a desktop environment. Let's jump straight to cloning the Git directory. You can copy paste the command from this page. Just be careful to start from Git and don't copy the first character, as that will not work on Windows. Once you run this, it will create a folder GPT-2 on your machine. You can check that by running the command dir on the prompt or check through Windows file folder window. GPT-2 as a directory should appear. Switch to that using the command cd gpt-2. You can check the contents of the folder using the command dir. My folder has additional files in it which we will get to soon. You can go back to the first article to guide you through the full download process. Use the command pip install -r requirements.txt. You don't need the upgrade portion in the middle. As I said before, you might need to run the individual commands separately too, which are listed in the article. Now we run the command to install requirements. As you can see, some components are showing up in red, which means the installation has a problem. The main one I had was with regex, which doesn't work with Python alone and needs C components to build. I tried multiple fixes like downloading Visual Studio components, trying different versions, but it just didn't work. I moved on and it worked fine, so the incompatibilities don't seem to affect the final outcome. Next, we need to download the models. This article gives you the current model names. More than their download size, the constraint is the processing power at your disposal. 774M, for instance, will barely run on an RTX 3090 in the training mode. Since I was using just the CPU, I was limited to training only 124M. Though the pre-trained 1558M runs okay on CPU if you have sufficient RAM. You can download the models by just copying the command and changing the model name appropriately. The downloaded model will be in the models subfolder. Switching to that, you can see that I have downloaded 3 models and there is an additional sci-fi model. Bear in mind that once you have downloaded a model, you can just move it around, copy it and change names because all the files related to that are contained inside the folder. Sci-fi in this case is just a copy of the 124M model because I want to train multiple models with different inputs and did not want to mess up the pre-trained version. Next, we will train a model, for which you will need a training data set. With the version we have downloaded, we just need a txt file with the delimiters inserted between pieces. You can keep your training file wherever you want as long as you remember the path. Here, I have created a text file with snippets from some of my favorite science fiction books from authors like Douglas Adams and Arthur C. Clarke. We will use the training set to train the model sci-fi, which is a copy of the 124M model. For training, you will need files in the src folder, but the paths in those are set to work from the parent GPT folder. You can either change those paths manually or can simply copy paste all the files into the parent GPT folder. I am showing you the easy way of copying the files. You can also modify the paths in the src folder itself if you would like to do that. Running the train.py file without modifying the paths will just produce an error, as the program cannot find the models folder and the files inside of it. You will also see several warnings about commands having deprecated. You should just ignore these because they are due to version changes in TensorFlow or other components. You can simply copy the files in the src folder and paste them in the GPT-2 folder, and that should work. You will need practically all of them for the model to work, so might as well copy them all and paste them in the parent GPT-2 folder. You can just use the Windows Explorer to copy and paste all these files, or you can use the command prompt, though the latter option is quite unfamiliar if you're like me and haven't used the old MS-DOS commands as a matter of routine. Here you can see we have all the files that we need in the GPT-2 folder, so we begin with the training. Here I am adding the model name to the command to specify which model to train. Train.py will use the lightest model for training by default, though the version we have downloaded incorrectly lists that as 117M instead of 124M. We anyway need to train sci-fi, so we need to specify the name of the model. That didn't work because I made the mistake of adding single quotes to the model name. Let's fix that. Now the model is training. Since I had trained this model over a few days, the checkpoint starts from 1530. You can change your dataset periodically and train the model. It will pick up from the point where you left it. You can stop training at any time by pressing Ctrl C. It will save the last checkpoint automatically. Next, we will launch Spyder, the IDE that comes bundled with Anaconda. Since we have launched Spyder from an environment with Python 3.7, this is what the IDE will be running, as you can check at the top of the screen here. Alright, you need to open the file interactive conditional samples to test drive the system. As you can see, the default model name listed here is 117M, which we will need to change appropriately. To locate the file, simply click the folder icon on top and choose the file in the GPT-2 folder. Back to the program. We will need to change the name of the model to 124M to generate our first sample, and press run. As you can see, the model 124M has loaded. Now we give it a prompt. We will use the same prompt for all the models so that we can compare the output. Depending on the processing speed, the model will take some time to generate output. Here we are. Going back up, we see that the model has produced some output with semi-coherent sentences. As you can see, From the very beginning, the output has no connection with the prompt and then degrades rapidly after that. While you can use it for some fun, it is not what you can call usable output. If you see the paragraphs below, they just go off on completely different tracks, particularly the last paragraph, which doesn't make any sense whatsoever. We will stop the model by pressing Ctrl C. To run the next model, we will simply change the name of the model in the program file to 774M and run it again. As you can see, model 774M has loaded and we will use the same prompt. This model will take more time to generate output because of the much higher number of parameters it has. In the meantime, we can look at the different options we have, which are specified in the paragraph where the model name is defined in the program. There are sample and batch size, which determine how many samples you get, and speed. There is temperature, which gives you more coherent output at 1 but becomes more random at higher values. There is top K, which becomes more deterministic but repetitive at values lower than the default of 40, and it overrides the temperature. Then there's top P, which again can override top K if you want more or less randomness in the output. You might want to play around with these parameters to see what kind of output each of them generates. For our purpose, I will leave everything at default. As you can see, the model is taking quite a while to generate output. It all depends on how much processing power you have at your disposal. You might have to wait for several minutes. Okay, we have our output. Let's see. As you can see, the model has produced content with no connection at all with the prompt. Though the sentences are more coherent than before, it still doesn't give you much that is usable. From the start, the model produces a bit of gibberish and just degrades from there. We stop the model by pressing Ctrl C and load the next pre-trained model 1558M. As you can see, the model takes longer to load. You can check that the correct model has loaded. Again, we use the same prompt and run the model. Since this is the largest set of parameters available for GPT-2, it is going to take quite a while to run. For me, the time was around 10 minutes. Perfect to get a nice cup of coffee. To save some time, I have cut out most of the waiting period so that we can look at the output directly. And here we have the output of the model. Let's see what the model has produced. Scrolling up a little, you can see the output is now related to the prompt and picks up right where the prompt left off. It gets the names right and focuses on photography, which is great. It makes up the names of some towns, but we can switch them out ourselves later. The first para sets the context that the text appears to be describing some kind of documentary. The following paras also stay connected to the theme, though the further along you read, the more disjointed it gets. Notice that the last para is completely disconnected from the topic or the theme. The good part is that the first few paras can give you usable output, provided you are willing to work on editing the text. Without further training or extensive editing, the usability of even this model is a little limited. Let's stop the model by pressing Ctrl C and load the model we have trained on some good old sci-fi material. We change the model name to sci-fi, leaving all the other parameters as they are, and we are good to go. We'll use the same prompt again and see what comes out. Since the model has only 124 million parameters, it shouldn't take much time to generate output. I won't be skipping ahead, and you can see exactly how long it takes on my system. And we have our output. Let's see. The first thing you will notice is that the output is in the form of a dialogue. This is because the snippets I fed it were mainly dialogue from sci-fi books like Hitchhiker's Guide to the Galaxy. You can also see that although it has again missed the name, it has managed to get the theme somewhat right, art instead of photography. I think that is close enough to the prompt. Throughout the dialogue, it sticks to the theme of art or artists and doesn't introduce any additional elements. The second thing you will notice is that it has assigned the same name to both the sides in the dialogue, which makes it a bit disconcerting. Not that Douglas Adams would mind that. As you continue down the text, additional elements from sci-fi keep surfacing along with random character names. You also find that the character is a robot, which might explain why many of them have the same name, Arthur. I wonder the fascination with the name though. It may be an homage to Arthur C. Clarke. Later on, add-ons to the name like new and dent also occur, which is quite common in sci-fi robot type situations. Now, for side-by-side comparison of the output, I have put all three pre-trained models next to each other. You see that the first model has just taken off on a tangent right from the start and keeps getting farther and farther away as we read along. It is hard to make any sense of the text as we keep proceeding. The first para starts with some talk about moviegoers, leaves that in the next para, and later on just rambles on with barely a coherent sentence. Moving on to the second model, again, there is no connection with the prompt. The problem here is that early on, it starts producing incoherent sentences, though not as much as 124M. It quickly jumps to mountaineering, then talks a bit about shooting pictures, but finally moves on and starts rambling. Moving on to 1558M, as we discussed before, it is quite a coherent output. It stays close to the prompt in the early parts and makes some sense. The first para is squarely on the prompt, then is linked with religion. Even town names like Kanyakumari and Bodh Gaya have religious significance. It just makes sense. The remainder, even though you have elements related to the name or theme or religion, is just rambling. Not very useful output. By the time we get to the last para, it just loses all semblance of coherence and essentially breaks down. While interesting, you can see that the elements are making less and less sense as we go along. I think the way to use this model as a bot would be to limit the output to 3 or 4 sentences, and maybe it will produce some interesting text that is related to the prompt while also adding some elements out of the blue. I don't see much more potential, at least without training. Moving on, let's compare the output of the trained model with the pre-trained version. I have put both side by side because the model sci-fi is based on 124M and it would be futile to compare it with models with higher parameters. Though both models miss the prompt, the character name being the prime miss, right away it is clear that the trained model carries much more coherence than the pre-trained version. As we talked about before, the dialogue doesn't make much sense, but it tries to stay close to the initial conditions. Character names do not change throughout, and the art theme also goes on right till the end. Even the naming choices and other elements stay mostly consistent. The sci-fi theme also shows up at the end. The other thing to keep in mind is that my dataset is not extensive by any standard, so the options available to the model have also been quite limited. Even though the model is still unusable and might not make much sense, I find it to be a major improvement over the stock 124M. Since it has been trained on science fiction, some of the common themes like robots and their naming conventions are visible. Though it is clear that training has made a difference, it is still nowhere close to the pre-trained 1558M, where you can limit the output to a few sentences and get a coherent output. I guess it is too much to ask of a very basic model with 124 million parameters. We already know what it takes to create a fully functional model like GPT-3, 175 billion parameters. A model that is roughly 0.07% the size of the fully functional thing can only do so much. Towards the end, it just breaks down, of course. Okay, so what conclusions can we draw from this limited experiment? My goal was just to put GPT-2 through its paces and see what it could do. And to be honest, I am both impressed and intrigued. The pre-trained models might not produce usable output, and I have no experience with GPT-3, but I can only imagine what it would be capable of with 120 times more parameters than the largest version of GPT-2. Recognizing its disruptive potential, OpenAI has not made it public, and rightly so. If you want to kick its tires, you will need to get access by permission only and can test it through an API. Having said that, the 1558M model does produce coherent output and sticks to the prompt for the most part. We have also seen that training improves the model output significantly, even in the case of 124M. I could not get my GPU to work with the model, that will require another video of its own, and also had a limited training dataset. The risk with a limited training dataset and running too many training cycles is that you risk overtraining the model. The conclusion then is that if you can find a large enough dataset to train the model and can train 1558M for a sufficient period of time, you can get coherent and possibly usable output. It's not an easy thing, as Google Colab or an RTX 3090 can only train 774M. Maybe multiple GPUs will do the job. Lastly, a large training dataset is required because you don't want to overtrain, similar to overfitting a curve to data points. If you do that, the model will just start going around in circles and become too repetitive. Here are some of my thoughts based on this experience. The model is going to be limited to the training input you give it, and it might be quite useful for some specialist applications. GPT-2 simply doesn't have enough parameters to be a good generalist. Within specialist applications, those that require constant new output won't work. You just can't get it to write your next stock market newsletter. At least not without extensive recoding. Even if you try feeding it some specific inputs through the prompt, there is no guarantee that the model will give you output that works. It will most likely just throw the new information in a blender with what it already has and spit out some parts that match and some that don't. Again, it is just an experiment, so I guess no harm, no foul. Narrow and specific topics are quite a different thing though. If you can feed it a few hundred volumes of philosophy, for instance, who knows what a capable model like 1558M will produce. That is why specialist applications based on transformers are moving ahead rapidly. So here we are, folks, my little experiment with GPT-2. I hope you enjoyed it as much as I did. Have fun.